In this question, we're asked to identify the intermolecular forces for the following compounds. And before we could do this, we need to draw the Lewis structures. In other videos on this channel, you can find detailed instructions of how to draw Lewis structures. This can't really be done without Lewis structures. I want to briefly review intermolecular forces without going into very much detail, and you can find these on other videos in this playlist. The first is dispersion, which is shared by all molecules. And again, not a lot of detail here, just which molecule, which type of molecules have it. The next is dipole, which is for polar molecules. The next is hydrogen, or just H bonding, which is going to be if you have an N directly bonded to an H, and O directly bonded to an H, or HF. And then finally, ion dipole, which is exactly what it sounds. Polar molecule and ion, like if you dissolve salt in water. Salt is an ionic compound and water is a polar molecule. That's not going to be possible here because these are all pure substances, so you can't have ion and dipole if you don't have a mixture. So the first one is iodine. We want to draw the Lewis structure. Iodine is diatomic, so the electronegativity of this iodine and this iodine are exactly the same, so there's no polarity here. If it's not polar, the only intermolecular force it has is dispersion. Nitrogen tribromide. The Lewis structure looks like this, and again, I'm just skipping right to the Lewis structure. If you need a review on that, please click on the other videos on this channel. This is nitrogen tribromide. So we have 3 bromines and a lone pair on the central atom. Therefore, they're not all the same. Therefore, this is polar. This has dispersion forces and dipole-dipole forces. It does not have hydrogen bonding because there's no hydrogen, much less a hydrogen bonded directly to that nitrogen. So it doesn't have this. Note, they all have dispersion forces. If something has dispersion forces and is polar, it also has dipole-dipole. If it has hydrogen bonding, it also has dipole-dipole, and it also has dispersion. So essentially, to check this box, you have to check these two as well. Same, to check this box, you also have to check this one. Nitrogen trichloride, which is the same as nitrogen tribromide, with the only difference being, instead of those being bromines, they're now chlorines, but the Lewis structure is identical because they're both chlorine and bromine are halogens, and this one's also polar for the exact same reason that this one is polar. The last one is carbon tetrafluoride. So in this case, we have a carbon bonded to 4 fluorines, like so. In this case, all the domains on the outside are the same, so they cancel each other out. This is a tetrahedron, so it doesn't exactly look like this, but shown in this way, like kind of like a plus sign, you can see that this fluorine is canceled out by this fluorine and vice versa, so there's no total pull. If you look at a vector diagram, you can see this for a tetrahedron, but I'm going to skip that for here. Since this molecule is nonpolar, because all outside domains are the same, this one only has dispersion forces. It doesn't have dipole-dipole or hydrogen bonding. So these are how you would identify the intermolecular forces in these molecules. Remember that the first job is to draw the Lewis structure.